So we're going to have 2/5 plus 3/20. All right, so there is our two fractions. And remember, you can't add or subtract a fraction unless the denominators are the same. And here the denominators are different. If the denominators aren't the same, we have to make them the same. So what I'm going to do is set it up. Okay, I'm going to figure out what my new denominator is going to be. Now, all the problems on page 8, what you can do is you look at the smaller denominator, which is 5, and you say, can 5 go into 20 evenly? If the answer is yes, then 20 can be your denominator. You can't say 5 because 20 can't fit into 5, but 5 can fit into 20, right? So 20 is going to be the denominator I'm going to work with. This should look familiar. It should look like equivalent fractions because that's exactly what this is. We're going to find the equivalent fraction here. So, 20 times what number equals 20? The number would be 1. 20 times 1 is 1. Whatever I do to the bottom, I have to do to the top. So since I multiplied the bottom by 1, I've got to multiply the top number by 1 as well. 3 times 1 is 3. We'll do the same thing up here. 5 times what equals 20? It's 4. 5 times 4 equals 20. What I do to the denominator or the bottom, I must do to the top. So 2 times 4 is 8. So our new problem is 8/20 plus 3/20. The denominators are the same, so now I can make 20 my denominator, and then we add 8 plus 3, 9, 10, 11. 8 plus 3 is 11. We can't reduce here. When 11 is your numerator, there's not much you can do from there. So the answer to this problem is 11/20. So the first thing we do, step 1, different denominators. Can the smaller denominator fit into the larger denominator evenly? If it can, then the large denominator becomes our new one. And then we work out our equivalent fractions to get our new numerators. And then we add. Let's take a look at another one. 2/25 plus 4/5. Once again, we're looking at our denominators. They're not the same, so we can't add them because they're different, right? So we have to make the denominators the same. So let me get my setup ready. $25 is my larger denominator, and 5 is the smaller one. Can 5 go into 25 evenly? Yes, it can. If you're not sure, don't forget you can always look at your fraction strips here. And as you can see, 5 times 5 is 25. So 5 can fit into 25 evenly. So 25 is going to be my new denominator. And now we do our equivalent fractions. 5 times something equals 25, and it's 5. 5 times 5 is 25. What you do to the bottom, you must do to the top. So 4 times 5 is 20. Let's do the next one. 25 times something equals 25. 25 times 1 equals 25. What you do to the bottom, you must do to the top. So 2 times 1 equals 2. My new math problem is 2/25 plus 20/25. 25 is the denominator, And then 2 plus 20 is 22. We can't do any reducing here, right? Because this is an even number, odd number. There's nothing that'll fit into 22 and 25. So this is our answer, 22/25. Let's keep going. Do one more for you. Let's try 2/6 plus 1/2. Okay. Our denominators are different, so let's see if we can make them the same. Can 2 fit into 6 evenly? Yes, it can. So let's do our setup. All right. Since 2 can fit into 6 evenly, 6 can become our new denominator. And now we can do our equivalent fractions. So 2 times something equals 6. And that would be 2 times 3 equals 6. What I do to the bottom, I must do to the top. So since I multiplied the bottom by 3, I have to multiply the top by 3 as well. 1 times 3 is 3. Let's do the top here. 6 times something equals 6. That would be 1. Which do to the bottom, do to the top. So 2 times 1 is 2. Our new math problem is 2/6 plus 3/6. Since the denominators are the same, we know that 6 is our denominator. And then 2 plus 3 is 5. We can't reduce anything here. We've got an even number and an odd number, not any multiples, so 5/6 is our answer. Now let's take a look at one that might seem hard, but really isn't, okay? The problem is going to be 1/4 plus 2/3 plus 7/12. That's right, we're doing 3 fractions at one time. But no matter how big it seems, the steps stay the same. Step 1, are the denominators the same? No, they're not. There's a 4, a 3, and a 12. Okay, step 2, what's my biggest denominator? 12. All right. Can 3 go into 12 evenly? Yes, it can. Can 4 go into 12 evenly? Absolutely. So that means that 12 is going to be our new denominator because all 3 can fit into 12 evenly. Okay, see that? 3 can go into 12 evenly and 4 can go into 12 evenly, so 12 becomes my new denominator. Now let's do our equivalent fractions, right? 12 times something equals 12. 12 times 1 equals 12. What I do to the bottom, I must do to the top, so 7 times 1, that equals 7. 3 times 4 equals 12. So 2 times 4 equals 8. 4 times 3 equals 12. So 1 times 3 equals 3. So whatever I did on the bottom, I had to do on the top for each fraction. My new math problem is 3/12 plus 8/12 plus 7. And that's going to give you 18/12. This is an improper fraction. This can't be. So we have to change it to a mixed number. So our numerator, 18, is divided by 12. 12 can go into 18 one time. So 12 times 1 is 12. I'll do my subtraction. 8 minus 2 is 6. then 1 minus 1 is 0, right? 1 is our whole number, and then we go clockwise. Our answer is 1 and 6/12. But if you look at 6/12, it looks like it can get reduced. Now 6 and 12 are both even numbers, so we could reduce by 2, right? Six divided by 2 is 3. 12 divided by 2 is 6. So now we have 3 over 6. And 6 is a multiple of 3, isn't it? So we could also reduce by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. Don't forget, we got to put our whole numbers back together, and that'll give us 1 and 1/2. Another way we could have reduced, let's go back to 1 and 6/12, is we could have said 6 and 12, they're multiples of each other. We could reduce by 6. We could go bigger. Six divided by 6 is 1, and 12 divided by 6 is 2. And then we put our whole number back with our fraction, and we get 1 and 1/2 again. So our answer is 1 and 1/2. So I know